Did you know that the largest volcanic eruption in recorded history was the 1815 eruption of Mount Tambora in Indonesia? This cataclysmic event was so powerful that it reverberated around the globe, leading to a dramatic drop in temperatures and earning the notorious title of the year without a summer. Picture this: the air thick with ash, the ground trembling beneath your feet, and a massive plume of smoke and debris shooting into the atmosphere, blotting out the sun for months. Today we'll explore the immense scale and significance of the Tambora eruption, a natural disaster that continues to shape our understanding of volcanic activity and its global effects. This eruption serves as a stark reminder of how nature can unleash forces beyond our comprehension. Scientists still study the event meticulously, analyzing its impact on the climate and the environments we depend on. To grasp the significance of the Mount Tambora eruption, we need to delve into the science behind volcanic eruptions. These geological phenomena occur due to the movement of tectonic plates beneath the Earth's surface. As magma rises to the surface, pressure builds up until it erupts violently. This eruption can release a cocktail of materials, ash, gas, and molten rock, into the atmosphere, which can have far-reaching consequences. Imagine a world where the balance of ecosystems is disrupted overnight. When Mount Tambora erupted, it didn't just affect the immediate vicinity. The release of vast amounts of sulfur dioxide and ash created a cloud that encircled the Earth. This cloud reflected sunlight away from the planet, causing a dramatic decrease in temperatures across the globe. The repercussions of this event extended far beyond Indonesia, impacting agriculture, weather patterns, and even human health on a monumental scale. The significance of understanding volcanic eruptions like that of Mount Tambora cannot be overstated. Volcanic eruptions are not just geological events, they are significant occurrences that can reshape entire civilizations. Throughout history, we've seen how volcanic activity can lead to the downfall of empires and the displacement of populations. The study of these events allows scientists to improve predictive models and develop early warning systems, ultimately saving lives and minimizing economic damage. As we dive deeper into this topic, we will uncover the intricate details of the 1815 eruption and its aftermath, exploring the chaos that unfolded in the months and years that followed. From the immediate destruction to the lingering effects on climate and human life, the story of Mount Tambora is one of awe and horror. So, buckle up as we embark on this journey through one of the most powerful eruptions in recorded history, uncovering the powerful forces that shaped our planet and the lives of those who lived through it. To understand the full impact of the 1815 eruption of Mount Tambora, we must first explore the conditions leading up to this catastrophic event. The years before the eruption were marked by an unusual series of geological activities and climatic changes. Indonesia, being located on the Pacific Ring of Fire, is no stranger to volcanic eruptions, but Tambora had remained relatively quiet for many years prior to 1815. This deceptive calm masked the immense pressures building within the Earth. In the early months of 1815, local residents began to notice strange phenomena around the volcano. Minor eruptions and increased seismic activity hinted at the brewing disaster. The volcano, which loomed majestically over the landscape, began to emit plumes of smoke and ash, alarming those living in its shadow. However, many were unaware of the true magnitude of what was about to unfold. By April 1815, the situation escalated dramatically. A series of explosive eruptions began, with the volcano belching out ash clouds that rose high into the atmosphere. The initial explosions were so powerful that they produced thunderous booms that could be heard from miles away. Local villagers, who had relied on the fertile land surrounding the volcano for their livelihoods, were soon engulfed in darkness as ash fell like snow, blanketing everything in sight. The initial phases of the eruption caused widespread panic and confusion as people fled from their homes and sought refuge from the chaotic landscape. On April 10, 1815, the eruption reached its climax in an event that would forever be etched in history. The skies darkened as the volcano unleashed a cataclysmic explosion, launching an estimated 160 cubic kilometers of volcanic material into the stratosphere. This was a monumental release of energy, equivalent to the power of multiple nuclear bombs. The eruption blew away the top of Mount Tambora, creating a massive caldera that remains visible today, a haunting reminder of nature's fury. The scale of this eruption was unprecedented, classified as a volcanic explosivity index, VI of 7. In comparison, The 1980 eruption of Mount St. Helens in the United States, which caused significant destruction, was only a VEI of 5. This means that the Tambora eruption was not only larger, but also produced far more ash and gas, influencing atmospheric conditions for years to come. As ash clouds spread across the region, they disrupted local weather patterns and initiated a series of climate anomalies that would ripple across the globe. The immediate area surrounding Tambora was devastated, but the effects would be felt far beyond Indonesia. In Europe and North America, residents would soon experience the chilling consequences of this eruption, leading to crop failures and widespread famine, as the sunlight struggled to penetrate the dense layer of volcanic ash in the atmosphere. In essence, the days leading up to the eruption were marked by uncertainty and fear, with signs of a looming disaster evident to those who paid close attention. But for many, the full scale of the impending catastrophe remained a mystery until it was too late. The eruption of Mount Tambora in April 1815 stands as a stark reminder of nature's unpredictability and the delicate balance of our planet's systems. As we move forward, we'll explore the eruption's devastating aftermath and the long-lasting impacts that this historical event had on the world. Following the cataclysmic eruption of Mount Tambora, the immediate landscape of Sumbawa Island was irrevocably altered. The once lush greenery surrounding the volcano was replaced by a barren wasteland, with the ground covered in thick layers of ash. Entire villages were obliterated, and the local population was thrown into chaos as they struggled to comprehend the devastation. The initial toll of the eruption was staggering, with estimates suggesting that approximately 60,000 people lost their lives due to the eruption and its immediate consequences, such as pyroclastic flows and collapsing buildings. In the days and weeks following the eruption, a humanitarian crisis unfolded. Survivors faced extreme shortages of food and clean water. The agricultural systems that had sustained them were in ruins, as fields became choked with volcanic ash. The situation was exacerbated by diseases which spread rapidly in the unsanitary conditions created by the eruption. Local authorities struggled to provide aid, and international assistance was slow to arrive, highlighting the dire need for a coordinated response to such a monumental disaster. However, the effects of Mount Tambora's eruption extended far beyond Indonesia. The ash clouds injected into the atmosphere had profound implications for weather patterns globally. The eruption released vast quantities of sulfur dioxide, which combined with water vapor to form sulfate aerosols. These aerosols reflected sunlight away from the Earth, leading to a significant cooling effect known as volcanic winter. In the Northern Hemisphere, particularly in Europe and North America, the summer of 1816 became infamous as the year without a summer. Temperatures plummeted by as much as 3 degrees Celsius, disrupting agricultural cycles and leading to widespread crop failures. Reports from various regions highlighted the unprecedented weather anomalies. Frosts occurred in June, and heavy snow fell in July. Farmers who relied on predictable growing seasons were faced with ruin, and food shortages began to spark unrest in communities. In the United States, the consequences of the eruption were felt sharply, especially in New England. Corn and wheat crops failed, leading to severe food shortages and rising prices. Discontent among the populace grew, resulting in protests and calls for government intervention. The economic impact rippled through society, affecting not only farmers but also the merchants and laborers who depended on agricultural production for their livelihoods. Simultaneously, Europe was grappling with similar challenges. Reports from various countries depicted a grim picture. Food riots erupted in France, while the United Kingdom experienced rising tensions due to hunger and economic instability. The cold, damp summer severely impacted livestock, compounding the agricultural crisis. The combination of volcanic activity and extreme weather conditions led to a rise in diseases, with malnutrition making populations more susceptible to illness. Beyond the immediate suffering, the eruption also sparked a shift in scientific understanding and societal attitudes towards natural disasters. The dramatic changes in climate caught the attention of scientists and scholars across Europe and America. The phenomenon of volcanic eruptions influencing global weather patterns began to be recognized as a significant area of study. This newfound awareness laid the groundwork for future research into climate science, weather forecasting, and disaster preparedness. Artists and writers were also inspired by the unusual atmospheric conditions. The year without a summer influenced works of literature and art, including Mary Shelley's Frankenstein, which was conceived during a summer spent indoors due to the cold weather. These cultural responses reflected the societal anxiety surrounding nature's power and humanity's vulnerability. In summary, the aftermath of the 1815 eruption of Mount Tambora was not just a local disaster, but a global event that reshaped climatic conditions and societal structures. The intertwined stories of survival, resilience, and adaptation to this disaster would echo through history, serving as a powerful reminder of the interconnectedness of our world and the far-reaching effects of nature's fury. In our next part, we will delve into the long-term consequences of this eruption, examining how it has influenced both geological study and societal changes over the centuries. As the dust settled from the eruption of Mount Tambora, the long-term repercussions began to unfold, shaping not only the immediate region, but also influencing global policies, scientific advancements, and cultural shifts that resonate to this day. The eruption was a turning point that highlighted the fragility of human existence in the face of nature's overwhelming power. In the scientific community, Mount Tambora's eruption marked a watershed moment in volcanology and climate science. Researchers began to recognize the complex interactions between volcanic activity and climate systems. This event spurred a wave of scientific inquiry into how volcanic eruptions could lead to significant climate changes. Scientists began to develop models to better understand the atmospheric impacts of ash and gases released during eruptions, which would eventually inform how we study modern volcanic events. The eruption also underscored the importance of preparedness for natural disasters. In the wake of such a catastrophic event, countries started to prioritize the establishment of monitoring systems for volcanic activity. These systems were designed to detect signs of impending eruptions and allow for timely evacuations, significantly reducing the risk to human lives. As a result, many nations established geological surveys and increased collaboration among scientists to share knowledge and expertise. Moreover, the global response to the climatic effects of the eruption led to a greater awareness of the interconnectedness of environmental systems. The realization that volcanic eruptions could influence global weather patterns helped lay the groundwork for modern climate science. It led to increased investment in research focused on understanding climate variability and change, paving the way for studies on anthropogenic climate change that are crucial in our current era. Culturally, the aftermath of the eruption gave rise to new artistic expressions and movements. The stark reality of the year without a summer inspired many artists and writers to reflect on humanity's relationship with nature. The Romantic movement in literature and art, which sought to express deep emotions and an appreciation for the sublime aspects of nature, found fertile ground in the wake of this disaster. Themes of nature's beauty, power, and unpredictability permeated works from this period, encouraging society to contemplate its vulnerabilities. Furthermore, the agricultural crises triggered by the eruption highlighted the critical need for food security and sustainable farming practices. As communities struggled to recover from crop failures, discussions about agricultural resilience began to take shape. This led to the development of more adaptive farming techniques, the importance of biodiversity in crops, and the need for better resource management to mitigate the impact of future disasters. In addition, the social consequences of the eruption were profound. The widespread famine and suffering that followed catalyzed movements advocating for social reform and improved governance. The lessons learned from the disaster emphasized the importance of community resilience and the need for societies to be better equipped to respond to natural calamities. In contemporary discussions about climate change and environmental sustainability, the legacy of the Mount Tambora eruption serves as a stark reminder of the potential consequences of natural disasters. As we face an era of increasingly extreme weather events, the lessons learned from Tambora remind us of the importance of preparedness, research, and sustainable practices to safeguard our communities against the uncertainties of nature. In conclusion, the eruption of Mount Tambora in 1815 was not just a moment of devastation. It was a catalyst for change across multiple spheres of life. From advancing scientific understanding to influencing cultural movements, the impacts of this monumental event continue to resonate in today's world. As we reflect on this incredible episode in history, we gain valuable insights into the complexities of our planet and the enduring relationship between humanity and the forces of nature. Thank you for joining us on this exploration of one of the most powerful volcanic eruptions ever recorded. If you enjoyed this journey, be sure to share your thoughts in the comments below and check out our other videos that delve into the fascinating world of natural disasters. This year, the world got to witness the extraordinary sight of the Sahara Desert, experiencing a rare rainfall event of the century. This extraordinary natural phenomenon is a testament to the unpredictable nature of our climate. The Sahara, known for its arid landscape, is often associated with extreme heat and dryness. However, this rare rain event brings new life to the desert, highlighting the impact of rainfall on this unique ecosystem. Join us on this thrilling journey as we explore the desert storm and its effects on the environment. From the rare weather patterns to the natural wonders that emerge, this video is a must-watch for anyone fascinated by the power of nature and the importance of understanding climate change. Get ready to be amazed by the facts of Sahara's transformation. The Sahara Desert has long been regarded as one of Earth's most arid and unyielding regions, covering nearly a third of Africa and stretching across multiple countries. Known for its blistering heat and seemingly endless sand dunes, the Sahara typically experiences less than 3 inches of rainfall per year, making any instance of precipitation a significant event. The desert's climate is influenced by high-pressure systems that keep the air dry, minimizing the chances of rain. These systems, combined with extremely low humidity, create an environment where some areas might go without a drop of rain for more than a decade. Yet against all odds, September 2024 brought a rare and surprising shift in weather patterns to the Sahara. This rain event, linked to a shift in the intertropical convergence zone, defied expectations as it pushed uncharacteristic storms into the desert, drenching some regions with a shocking 500 to 1,000% of their average monthly rainfall. For context, areas that would usually receive just a fraction of an inch saw a downpour equivalent to several years of rain in only a few days. The impact of this event was both immediate and transformative. The usually dry riverbeds swelled with water, while stretches of barren sand began to show hints of greenery. Such bursts of plant life, although temporary, alter the landscape significantly, providing a brief glimpse into how drastically the environment can change with the right conditions. This phenomenon is rare in the Sahara, as the vast desert climate resists change, largely shaped by intense solar heating and dry atmospheric conditions. In this video, we'll dive deep into this extraordinary occurrence, exploring why rainfall is such a rare event in the Sahara, the unique factors that brought rain to the desert in 2024, and how this event challenges what we know about climate patterns in some of Earth's most extreme environments. The rarity of rainfall in the Sahara highlights the complex systems that govern desert climates, and why a rain event like the one in 2024 is so extraordinary. The Sahara's environment, with its intense heat and arid conditions, has been shaped by high-pressure systems and a unique geographical location that typically prevents rain from reaching its vast expanses. In most cases, weather fronts carrying moisture dissipate before reaching this region, meaning that even when clouds pass over the Sahara, they rarely release rainfall. This recent rain event was driven by the unusual movement of the Intertropical Convergence Zone, ITCZ, a belt of low-pressure air near the equator. The ITCZ is vital to climate systems as it impacts weather patterns across various tropical and subtropical regions. Usually, the ITCZ moves northward and southward in a predictable manner. However, in 2024, it shifted further north than usual, pushing humid air into the Sahara. This allowed thunderstorms and rainfall to spread across the desert landscape, an occurrence that some scientists estimate might only happen once every few thousand years. The effects of this rainfall are not only visually striking, but also ecologically significant. As the rain fell, it triggered a rare greening effect in some areas, where dormant plant seeds absorbed the sudden influx of moisture and sprouted in a matter of days. This brief transformation, where the desert takes on a green hue, offers insights into how even small changes in precipitation can influence ecosystems. For many desert plants, which have adapted to survive with minimal water, such rainfall can catalyze quick growth cycles, allowing them to take advantage of the rare wet conditions before the desert returns to its usual dryness. In addition to plants, this increase in moisture attracted various forms of wildlife. Birds, insects, and small mammals were observed taking advantage of the newly available water sources. For researchers, observing the interaction between rainfall, plant growth, and animal activity offers valuable insights into the Sahara's resilience and adaptability in the face of changing weather patterns. The recent rainfall in the Sahara Desert has not only been a rare event, but also a dramatic spectacle that brought together diverse natural phenomena typically unseen in such an arid landscape. In particular, the combination of sudden downpours, intense thunderstorms, and even occurrences of hail turned parts of the desert into a temporary oasis. These storms, while a blessing for vegetation and wildlife, presented significant risks to local communities and ecosystems unaccustomed to handling large volumes of water. Flash flooding, a direct consequence of these intense rains, is one of the most dramatic and immediate impacts. Due to the Sahara's dry soil and lack of established river systems, water from heavy rainfall cannot be absorbed quickly, resulting in rivers of water flowing across the landscape. In some areas, this has led to rapid erosion as the powerful floodwaters carved out new gullies and moved massive amounts of sand. Some regions, particularly those with human settlements, experienced temporary rivers forming along roads and around structures, showcasing the Sahara in a state rarely seen by those who live within or study it. These floods also pose risks to local residents and animals, many of whom were caught off guard by the sudden deluge. For people living in or near these affected areas, the rain brought both relief and hazards. On one hand, the availability of water is a welcome change, essential for crops and livestock. However, the intensity of the storms and the resulting flash floods disrupted daily life and raised concerns about safety in areas without robust infrastructure to manage such sudden water flow. In addition to flash floods, the storms, lightning, and thunder were exceptional to witness in this otherwise dry environment. With vast open landscapes and minimal vegetation, these electrical storms illuminated the desert, creating striking visual displays against the sand dunes. Such phenomena are a powerful reminder of how unique weather conditions can transform a landscape as formidable as the Sahara. This event has piqued the interest of meteorologists and climate scientists alike, as it demonstrates how shifts in atmospheric conditions can lead to unusual weather patterns. Researchers are now analyzing how these changes might reflect broader shifts in climate dynamics, particularly with climate change influencing weather extremes. This recent rainfall event serves as both a fascinating case study and a reminder of the interconnectedness of Earth's weather systems. As scientists observe the Sahara's rare transformation from arid desert to a briefly verdant landscape, the focus is now on understanding the long-term effects of such a significant rain event on the region's ecosystem. For example, even though the vegetation brought by this rainfall is temporary, it supports a quick burst of life, from plants to insects and animals, creating a rich, if brief, environmental cycle. Animals, especially desert species adapted to sparse water sources, have been able to access pools of rainwater, allowing them to thrive in a way rarely seen in this extreme environment. Birds and smaller mammals, often elusive in dry conditions, have been observed in these temporary oases, feeding on new vegetation or taking advantage of the abundant insects that emerge with the rain. For the Sahara, such events are particularly fascinating because they can also introduce changes to the soil composition and fertility, even if temporary. The rain has nourished seeds lying dormant in the sand, causing vegetation to appear that has lain hidden for years, if not decades. These green patches, although short-lived, could provide researchers with clues about what ancient Sahara environments may have looked like and how vegetation patterns can adapt to extreme, unpredictable conditions. By studying soil samples, scientists hope to better understand how the Sahara's landscape responds to rare rain events and whether this event may leave a lasting impact on the desert's terrain. Meteorologists and climate scientists are keenly watching for signs of potential shifts in climate that could make such events more common. If rain in the Sahara does become more frequent, it could mean broader changes for ecosystems, agriculture, and the people living on the desert's edges. For now, the rare rainfall serves as a valuable natural experiment, giving researchers a chance to analyze the factors driving such extreme weather. It underscores the delicate balance of the Sahara's ecosystem, which operates under such precise conditions that even a small shift in rainfall can create massive cascading effects. As this unprecedented event fades, what remains is a landscape shaped by fleeting abundance, offering new data and a reminder of nature's unpredictability. This unusual occurrence leaves scientists with much to study and serves as a powerful example of how weather patterns can bring unexpected transformations even in Earth's driest and most formidable environments. Thank you for joining us in exploring the Sahara's rare rainfall. Don't forget to check out more of our videos on climate phenomena and natural wonders. Hurricane Helene, one of the deadliest storms to impact the United States in recent history, struck with unrelenting force in late September 2024. This powerful Category 4 hurricane made landfall in Florida's Big Bend region, a coastal area not typically accustomed to storms of this magnitude. Helene's arrival marked the strongest storm ever to strike this part of Florida, and was catastrophic in terms of both wind speed and storm surge, leaving a path of destruction across the southeastern United States. Initially, meteorologists noticed signs of potential tropical cyclone activity on September 17, 2024, when a disturbance formed in the western Caribbean Sea. This system rapidly intensified, influenced by the Central American Gyre, a broad area of low pressure, and the Madden-Julian Oscillation, which together created the perfect breeding ground for hurricane development. Within a few days, on September 23rd, the system gained enough organization to be designated Potential Tropical Cyclone 9. By the following day, the storm had strengthened into Tropical Storm Helene, gaining momentum as it traveled northward toward the Gulf of Mexico. Helene's intensification was swift. It reached hurricane status on September 25th as it entered the Gulf with ideal conditions for strengthening: minimal wind shear, high humidity, and sea surface temperatures exceeding 86 degrees Fahrenheit. These factors fueled the storm, allowing it to intensify quickly into a Category 4 hurricane by September 26th. The storm's enormous size also posed a unique threat. Meteorologists noted it was among the largest hurricanes in recent memory, exposing an extensive area to severe winds, rain, and the risk of tornadoes. As Helene approached Florida, evacuation orders were issued across counties in the Big Bend region and along the Gulf Coast, where storm surge was anticipated to be devastating. Unfortunately, due to the storm's rapid intensification, not all residents were able to leave in time. Helene's impact upon landfall was catastrophic, with winds over 130 miles per hour and storm surge flooding reaching unprecedented heights, inundating low-lying areas, uprooting trees, and cutting off entire neighborhoods. In the hours following landfall, Hurricane Helene continued its relentless path of destruction through the southeast, pushing inland with hurricane-force winds and torrential rains that left entire communities submerged. Although Helene's wind speed slightly reduced as it moved inland, the storm's intensity remained formidable, sweeping through Georgia, South Carolina, and up through North Carolina, with powerful gusts and severe rainfall. This deluge caused widespread flooding that overwhelmed rivers and creeks across the region, with some areas receiving over 20 inches of rain within a short period. As the storm progressed, North Carolina and Tennessee saw some of the worst inland flooding, with rivers like the French Broad and the Little Tennessee overflowing their banks. Small towns and urban areas alike were transformed by flash floods, which destroyed homes and forced many residents to evacuate or seek shelter in emergency facilities. In Atlanta, the effects were also severe. City infrastructure suffered and highways were cut off due to sudden water accumulation, making it nearly impossible for rescue teams to reach certain neighborhoods. The flooding was compounded by multiple tornadoes spawned as the storm traveled further north. South Carolina and eastern Tennessee experienced these tornadoes in high frequency, leaving downed power lines, destroyed buildings, and debris strewn streets in their wake. In Virginia, floodwaters caused additional disruption, leading to landslides in mountainous areas that further hindered rescue efforts. As Hurricane Helene moved deeper inland, it continued to wreak havoc on power grids and vital infrastructure, leaving millions without electricity across multiple states. The massive storm, which had already brought extensive damage to the Gulf Coast, saw its size contribute to the severity of outages and infrastructure destruction even far from the coast. Transmission lines, utility poles, and power stations in North Carolina, South Carolina, and Virginia took heavy damage from Helene's strong winds and sustained rainfall, rendering countless homes and businesses powerless. This disruption added an additional layer of hardship for communities already dealing with flooded roads, damaged properties, and scarce emergency resources. In addition to power outages, contaminated water supplies emerged as a significant concern for residents in the affected areas. In Florida, sewage systems overflowed, and storm surge combined with heavy rain led to water contamination. Similar contamination spread in Georgia and the Carolinas, where overwhelmed sewer systems and failing wastewater facilities created health risks for those exposed to polluted floodwaters. Emergency crews worked to distribute clean water to as many people as possible, but the sheer scale of the impacted areas created logistical challenges. Health officials warned of waterborne illnesses, and cases of skin infections and other flood-related ailments began to rise. Moreover, Florida's coastal cities, particularly Tampa Bay, faced significant challenges as the record-breaking storm surge began to recede. Roads were left littered with debris, sand, and mud, and many buildings sustained lasting damage. Cleanup crews mobilized to remove fallen trees, overturned vehicles, and wrecked property, yet the scale of the devastation slowed recovery efforts. In the aftermath of Hurricane Helene, communities across the southeastern United States began to grapple with the long road to recovery. The impact was especially pronounced in the hardest-hit areas, like Florida's Big Bend region, where homes and businesses were left in ruins and essential services remained largely unavailable. As people returned to assess the damage, many found their properties either irreparably destroyed or requiring extensive repairs. In coastal towns, the cleanup was underway with local and federal agencies working around the clock to clear debris, restore utilities, and provide emergency aid. Still, shortages of critical supplies combined with the widespread power outages and water contamination created major obstacles for recovery efforts, and further inland flooding continued to pose a threat for several days after the storm had passed. In North Carolina and Tennessee, heavy rainfall overwhelmed rivers and dams, leading to additional evacuations in low-lying areas. Rescuers remained on high alert, deploying helicopters and boats to assist residents trapped by rising waters. Organizations like FEMA, the Red Cross, and the Salvation Army provided food, shelter, and medical assistance to thousands displaced by the hurricane, yet the need for aid continued to grow with each passing day. Local leaders emphasized the importance of resilience and community solidarity, as volunteers and neighbors banded together to support those most affected by the storm's aftermath. In a testament to the widespread destruction left by Helene, it became clear that the storm's legacy would shape disaster response protocols for years to come. Government officials, emergency responders, and meteorologists all reflected on Helene's unprecedented impact, emphasizing the need for updated hurricane preparedness measures. As rebuilding efforts unfolded, communities also pushed for stronger infrastructure and improved flood defenses to withstand future storms. Although Helene's devastation left a lasting mark on the southeast, the resilience of these communities shone through as they began the long journey toward recovery and rebuilding.